Hi guys, welcome back to the vlogs.
Okay, permutations and combinations are what we're going to talk about today. You remember probably when you were younger, I know 8th grade does this, I think you do it like in 4th and 5th grade, where you make tree diagrams when it says you have heads and tails, they're red, green, yellow, how many combinations can you come up with? And you draw it out, all out, and you do that, yes? You remember doing that type of stuff when you were younger? Okay, we're going to talk about how we can do that in a simpler, quicker form. Okay? So the tree diagram is like a good method to use and everything, but when we get lots of information, we want to use something called this fundamental counting principle. Fundamental counting principle is when you take whatever your event 1 is and your event 2 and you multiply them together to figure out how many combinations you can get. So if I have 6 shirts and I have 7 pairs of pants, how many combinations can I get? Well, I do 6 times 7. Okay? Here it shows you have bread, meat, and cheese. Okay, bread, meat, and cheese. How many choices can you do with just bread and meat? Well, I could do 40 because 5 times 8. If I want to do bread, meat, and cheese, because I have 5 breads, 8 meats, and 6 cheeses, I get 240 choices of sandwiches I can make. Okay, you have 2 dice. How many different combinations can I have? I can have 36. I multiply them together. It is called the fundamental counting principle. So when they ask you to use the fundamental counting principle, you're just multiplying the stuff together. Okay? Now, with that being said, we're going to go into some other stuff. Okay. The Select Ice Creamery sells 8 flavors of ice cream, 3 types of cones. How many single scoop combinations can you buy? What do I need to do?
8 times 3.
Which is?
24.
24. Okay? 24 types of ice cream that I can purchase. Simple enough? Hopefully.
Does it get harder?
It does get a little harder, but it's actually all calculator work and then a little bit, so. Victory Shoes sells red, blue, green, and yellow sneakers. They come in low top, high top, and extra high top. If you order a random pair of shoes, what's the probability you get your desired red or blue, low or extra high top sneakers? This is where it gets harder. Because you have to do a little thinking. What do I need to do first?
Wait, 2 minutes ago?
What do you think I need to figure out first?
How many shoes are?
Okay, how many, like,
How many high, low, and extra high tops are?
you want the okay, you're jumping forward, yes. You have red, blue, green, and yellow. They come in low top, high top, extra high. If you order a random pair of shoes, what's the probability you get your desired red or blue, low or extra high? So what do I need to figure out first?
It shouldn't be like 1/3.
Wouldn't it be how many?
Shouldn't it be what?
Isn't the answer like 1/3?
It is, but how do you get there?
Well, I did 12, and then
Why'd you do 12? Where'd you get 12
it's
from?
only counted, it's red, blue, green, yellow, times.
Okay, you did red, blue, green, yellow, times
4 times
low, high, extra high. 4 times 3. So you get 12 total options that you can choose from, right?
3. Yeah.
Okay, so that's what goes on the bottom of my fraction because it's the total combinations I can have.
Yeah, and then he put it on over 4 because it's the red, blue, and then extra.
Okay, good. So then you take red, blue, which is 2, and you multiply it by lower, extra high, which is 2 options, and you get
4.
4.
And
So
then
I
you
get
simplify
4
that.
12ths, and I reduce it to 1/3. Does that make sense? Okay? So that's what you're doing, just break it down. You want to find the total options overall first, so that you have that as the bottom part of your fraction. And then, whatever specifically it's asking for goes on top.
Okay.
Okay.
That is wonderful. I want you like extra. Oh, okay.
Factorials. We're gonna talk about factorials. On your calculator, there should be a factorial button. On this one, I have no idea where it is.
I forgot I have this in here.
Let me see.
Oh,
Aha, okay.
okay.
On your calculators, if they don't have a factorial button, it's under PRB, which stands for probability. Factorial buttons would be under PRB, which stands for probability. So hit PRB, okay, and it's gonna give you 3 different options, most likely.
Why is there exclamation mark?
Because we're gonna talk about what that means. Okay, so probability. They give you 3 options. You should see buttons that look like this. NPR, right?
Yes.
NCR, and this. Okay. NPR stands we'll talk about that type of probability, we'll talk about this type of combination, and we'll talk about this. This is a factorial. That's what this is called, a factorial. Okay? Factorials. It's the product of all positive integers less than or equal to n. Meaning this. If I have n factorial, it's saying n times that number minus 1, times that number minus 2, times that number minus 3, until you get down to 1. You never minus it to multiply by 0, because that would be stupid. Anything by 0 is 0. Okay? So, when I want to figure out what factorials are, let's look into this. Plug into your calculator. You have to press the button 7 first, and then press that factorial button and tell me what you get.
7 exclamation mark.
5,040.
You get what?
5,040.
5,040, okay?
54.
Here's why. This is what it did. It did 7 times 6 times 5 times 4 times 3 times 2 times 1 for you. What do you get when you do 7 times 6 times 5 times 4 times 3 times 2 times 1?
50, 40.
50, 40. It's an easier way so that you don't have to write everything out.
Whoever thought of that as a genius,
What?
I
bro.
think this button is on.
Yes, it is. It's under PRB. Help him there, Kaden. It should be. What? That's because your calculator is a graphing calculator and you're not supposed to have this yet. Yours is gonna be under, let me
She's it over or she's
math. And then you have to go over to probability.
I don't see it on this.
Let me see your calculator.
Yeah.
It might not be a good enough one then.
Just tell me order.
Yours is gonna be under,
No, don't say.
Okay, yours is different. See how in orange yours has n factorial, NCR, and NPR? You have to press the orange button and then press that and it'll give it to you. Okay. So that is what you're doing. What do you get when you do 10 factorial?
3, 6, 2, 8,
Oh,
8,
really
0,
big.
0.
3, 6, 2, 8, what?
8, 0, 0. Another 8.
And then 0, 0.
Yes.
Beautiful. See how much longer this would take if I had to multiply it all the way out? What do you get when you do 0 factorial?
1.
1. 0 factorial always equals 1. Okay? So, that's what we're going to do. When you see that factorial in an equation, I'm going to use that button because it's going to make my life easier. Okay, permutations. Permutation is an ordered arrangement of a set of objects. Order matters. So if your homework, if a problem says order matters, or if it says you can't repeat numbers, or you can't repeat letters, that means order matters. I use a permutation. Okay, that's what this one is right here. A permutation. Okay, number of permutation, the order matters. Okay, do you see this formula? N factorial over n minus r factorial. Okay, we'll talk about what we do with that. But that is what this button does as well. It is that equation. Okay, and we'll talk about how we plug things in a second. But order matters on permutations. Order matters. That's important to know. If you don't know which of these two order matters in, you're going to screw it up and get wrong answers. Okay? Permutation, order matters. How many permutations are there of 10 digits, 0 through 9, of the 10 digits, 0 through 9? So if it says permutations, what does that mean?
Order matters.
It means order matters. How do you think I can solve how many combinations there are when order matters like that?
Would you put 9, the NPR, and then enter?
Would I put 9 what?
Hold on, no.
There aren't 9, there are 10
Oh.
digits, 0 through 9.
10 and 10.
So it would be 10 what?
NPR 9.
NPR. And then enter. Nope, that's that. No,
Mm-mm.
theirs.
Nope. Permutations, okay? It doesn't have anything else specific on it, it just says there's 10 digits, right? So I do.
Well, we have to multiply. Oh. It's
So
that.
how many?
It is that.
Wait.
3,628,800, okay? because it doesn't tell us anything else specifically, it just says how many permutations are there. So it doesn't say that there's like a first, second, and third place, how many permutations. This is just straight up permutation.
Oh.
So I just do 10 factorial.
So like say it gives us specific numbers.
Yes, we're gonna
That's
talk
what
about
we
that.
have to-
We're gonna talk about
Okay, that makes more sense.
Okay, so here, I've got two other, okay, look at this one. This one's a little bit more specific. Let me move it over. How many permutations are there of 2 letters from the 26 letters of the alphabet? Each letter can only be used once, meaning order matters. Because if I choose an A for the first one, I can't choose an A for the second one. Okay? So how do you think I could set that up? How do you think I could set that up? How many total letters do I have to choose from? 26. Does order matter?
Yes.
Okay, what does that formula tell me? It was n minus what? N minus r. What do you think my rate is in this case? 2. So I have 26 minus 2 permutation. Okay, now look. We're going to talk about this in a second, or I'm going to talk about this to you, but 26 means that I have 26 times 25 all the way down to 1, right? This means that I have 24 permutation, yes? Think about this. If I have something in a fraction and it's 26 times 25, 24, 23, 22, 21, okay? And on bottom I have 24 times 23, 22, 21, all the way down to 1. What cancels out?
24.
Anything below
Anything below
24, right? So what 2 numbers am I actually multiplying together? 26 and 25. Another way that this is represented is through that NPR, because order matters. Meaning, when you plug it in your calculator, you say 26, and then you say P, and then you would say 2. And it's going to give you the same answer. So try that for me. Try 26
650.
P2, and you get what?
650.
Okay, what is 26 times 25? Double check it.
Same thing.
Same thing. So when you are setting it up in this form, this stands for the number you start with. This stands for your rate. So my number is 26. Notice how I do not put 24 down here. I put 2 because I have 2 spaces to fill. Okay? So that's where that number goes. So 26 permutation 2.
And what does the P stand for again?
Permutation.
Permutation.
It's a
No,
permutation.
I was writing stuff down. Shut up.
Okay, now look at this one. 100 people enter a contest where there is a first, second, and a third prize. How many different ways are there for the prizes, or I should say prizes, not prices, for the prizes to be awarded? Assume that a person is not allowed to win more than once. Okay, how many people do we have?
100.
Does order matter?
Yes.
Yeah.
Yes. So we have 100 people. How many places do we have?
3.
1, 2, 3.
1, 2, 3. First, second, third. So how do you think I set that up?
100 P.
Mhm.
1.
100 P3.
170,000.
Oh yeah.
100 P3.
Slightly, but I do.
What'd you say you got, Kaden?
970,200.
Yeah, 970,200. That's how many combinations of people that could win in a race. So think about the flying pig. Do you know how many people enter that race every year almost?
Too many.
Like 32, 35, 40,000, stuff like that. Think about how many combinations of winners there could be for second and third.
Time to look at
Time like that?
it.
You see what I'm saying? Okay? That's why we want to do this stuff with our calculator. The next thing, the last thing we need to talk about is combinations. Combinations is this formula here, NCR. In a combination, it is a selection of elements of a set where the order does not matter. So when the order does not matter, you use combinations. When the order matters, use permutations. Do you notice this formula is a little different? It's n factorial over n minus r factorial times r factorial. This button here, again, will do the work for you. Okay? So, with that being said, I have just 2. How many combinations of 2 cards can be formed from 4? How do you think I set that up? How many combinations of 2 cards can be formed from 4?
Couldn't you do 2C or?
No. What do you think you do? How many combinations of cards can be, how many combinations of 2 cards can be formed from 4?
C and then,
Wait, it was 4 and 2.
It was 4 and 2, yeah. How many combinations of 2 sets of cards can be formed from 4? What's your overall total? 4.
wait, what?
8 is not your overall total.
No, sorry, no,
You
no,
have
no.
4 cards to choose from.
Hey, I measured.
You have 4 total cards to choose from, right?
Uh-huh.
And how many cards do you want in the end?
2.
2. So how would I set that up in a combination? 4 C2. 4 C2. What do you get?
Oh, I said 2C4.
Yep, you did say
I was close.
you get 6. Now, if I represented that in this form here, remember it's n factorial over n minus r factorial times r factorial. My n is 4. My n minus r would be how many?
4 minus.
Yeah, 4 minus 2, which is 2. And then my r is
6.
2, right? If I write this out, that
wait,
means I
wait,
have
wait.
4 times 3 times 2 times 1 over 2 times 1 times 2 times 1, right? Look at what happens. And this makes, what's 2 times 3?
6.
6. That's what they did.
Got that one right. That's
They
where I
did
got
that
my 6.
in a shorter form for you. Okay? Last part. A set had 14 elements. How many subsets, it should say subsets, sorry.
Subsets.
How many subsets with 5 elements are there? A set had 14 elements. How many subsets are there with 5 elements?
5C14.
What do you want to do?
What if you
Yes,
5?
it's 14. 5C. It's 14 5C. So 14
Coming up.
C5, right? Which is the same as saying 14 like this, and then 14 minus 5 is what? 9, and then times 5, right? What's 14C5? 2002. Now, if I had to write it out, remember it would be 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, over 9, 8, 7, 6, 5, 4, 3, 2, 1, and then 5, 4, 3, 2, 1. Cancel. Okay? And then this makes 6. 4 and 5 make 20, right? I would keep reducing 9 and 8, 9 and 8, 7, 6 can go into 12, making it 2. 5 goes into 10, making it 2. 4 goes into, no, 4 and 2 can cancel, giving you 14 times 13 times 11, which would give you the same as 2002. It's a much quicker way to do it. Kayla?
Come on, Faith.
So,
I can be
permutations
in
and
this.
combinations.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Faith?
This is
We're
how you
twinning today and we didn't plan it.